Hello, welcome back. Let's try this problem. A study reported that the mean BMI of male adults in a country is 28.5 kilogram per meter square. A researcher gathers a random sample of 20 male adults from one city and found that the mean BMI is 30 kilogram per meter square. The standard deviation is 3 kilogram per meter square. Now what we want to do is we want to find the 95% confidence interval for the mean BMI. Okay. So to get the confidence interval, okay, we say here that the confidence level is 0.95, which means that the alpha is 5%. Okay, so here n is 20, x bar is 30, okay, and the standard deviation is 3. So this information comes from the sample, right? So the 95% confidence interval for the parameter mu is given by x bar plus or minus t times 1 minus t times SE. Right. That t here is the it comes from a t distribution with n minus 1 degrees of freedom and 1 minus alpha over 2, because this is a two-sided confidence level, right? So okay, so here we look at the table, and that's going to be equal to 2.093. Then just simply put that in here, okay, and we want to put that in this equation. But first we have to solve the standard error. The standard error is s divided by square root of n, and it's gonna be 0.7671. Now the margin of error will be t times SE. This one here is the margin of error, and that's gonna be 1.404, right? Now the 95% confidence interval, just put them in here in this equation. We say that it is between 28.596 and 31.404, right? Meaning we are 95% confident that the true mean is between these two numbers here, 28.6 and 31.4. Okay, there. Okay, right. Now suppose we want to test, okay, if the mean in the city is equal to the mean in the country, right? So that means that the null hypothesis is mu is equals 28.5, and the alternative is that mu is not equal to 28.5. Now again, we're going to use an alpha of 5% here, and as before, this is the characteristic of the sample. Now from here we can get the standard error. Okay, it's gonna be 0.671, just like the one in the previous problem, right? Now the test statistic would be x bar minus mu divided by SE. Okay, so x bar is 30. Your mu here is the hypothesized mean, which is 28.5, and the standard error is 671. It comes out to be 2.2. Now we're going to compare this with the critical value, right? Okay, the critical value is 2.093. Now with 19 degrees of freedom. So we're saying here that alpha is 5%, so you have 2.5% on both sides. Okay, and this is negative 2.093 and positive 2.093, and the critical test statistic happens to be positive 2.2, which is here. Okay, therefore it is in the rejection region, so we reject the null hypothesis. Okay, and conclude that the mean is different from 28.5. Okay, next. Now suppose we are going to test this null hypothesis. Now it's not gonna be the two-sided test, but it's a right-tailed test. Okay, and we want to get the power of the test when the true mean is mu1. Okay, remember that when you do the test, there are two types of error. No? So alpha is the probability of committing a type 1 error, which we are going to set at 5%. And beta is the probability of committing a type 2 error, right? So here we want to determine the power of the test, okay? So your mu0 here is 28.5, and the mu1, the true mean, is 30, okay? The size is 20, and the standard deviation is 3, okay? So here we can get the standard error, just as before, it's 6.71, okay? And we use this formula for the power, right? Now, since this is a one-tailed test, then we will be getting the z of 1 minus alpha, and that's just 1.645, okay? And you put all those things together here, right? We see that the one inside this term here is going to be 0.591, and we want to get the area to the left of 0.591, and that's 723, okay? So that's the power of the test, okay? So this test has 72.3% power, okay? So remember that beta is probability of failing to reject HO, given that HO is false, no? Okay, so in this case here, this is the probability that you fail to reject HO, meaning you say that, mu is equal to mu0, given that the mean is indeed, mu1, okay? Yeah? And then power is 1 minus beta, the complement of this. Now, so we say here, okay, the complement of this, we say is the probability that, you reject mu0 given that the mean is, mu1, okay? In other words, this is the probability that you conclude that, the mean is greater than 28.5, okay, given that the mean is actually 30, okay? So that's the power of the test. Now here, we want to find the minimum sample size so that the power in this test is at least 90%, okay? So again, we identify the parameters here. Alpha is 5%, mu0 is 28.5, mu1 is 30, standard deviation is 3. Now the power is 0.9, okay? So, okay, z of 1 minus alpha is 1.645. Okay, z of power is 0.9, so you look it up in the table, it's 1.282, right? Now you want to get this term here, no? So just simply put them all together, right? Okay, and it turns out to be 34.255, okay? So n is equal to 34.255, so you have to round it up, okay? And you say that for you to have a power of at least 90%, your sample size has to be 35 or greater, right? Okay, so that concludes our example on confidence interval testing, hypothesis testing, calculating for the power, and calculating the sample size such that a certain level of power is achieved. Okay, so thank you. I hope you enjoyed the video and this is useful for you. Visit my website. Thank you.